Today's lesson is on comparing linear and nonlinear functions. First, we'll look at our vocabulary. The graph of a linear function shows a constant rate of change. A nonlinear function does not have a constant rate of change, so its graph is not a line. For our first example, we're identifying functions from tables. Does the table represent a linear or nonlinear function? Explain. So for A, in our table, we go from 3 to 6, so we're adding 3. And then from 6 to 9, we're adding 3. And from 9 to 12, we're adding 3. And for Y, we go from 40 to 32, so we're subtracting 8. And 32 to 24, we're subtracting 8. And 24 to 16, we're subtracting 8. As X increases by 3, Y decreases by 8. The rate of change is constant, so the function is linear. And for B, we're going from 1 to 3, so we're adding 2, and 3 to 5, we're adding 2, and 5 to 7, we're adding 2. For Y, 2 to 11, we're adding 9, 11 to 33, we're adding 22, and 33 to 88, we're adding 55. As X increases by 2, Y decreases by different amounts. The rate of change is not constant, so the function is non-linear. For our second example, we're identifying functions from graphs. Does the graph represent a linear or nonlinear function? Explain. So for A, if we look at our graph, we can see the graph is not a line, so the function is nonlinear. For B, when we look at our graph, we can see that we have a line, so the function is linear. Now we have an additional example. You can pause the video and try it on your own, or you may follow along. Does the table or graph represent a linear or nonlinear function? Explain. So for number 1, for X, we go from 0 to 7, so we're adding 7, and 7 to 14, we're adding 7, and 14 to 21, we're adding 7. For Y, we go from 25 to 20, so we're subtracting 5, 20 to 15, we're subtracting 5, and 15 to 10, we're subtracting 5. So this table would be linear. As X increases by 7, Y decreases by 5. For number 2, for X, we're starting with 2, and we're going to 4, so we're adding 2, and 4 to 6, adding 2, and 6 to 8, adding 2. For Y, 8 to 4 is subtracting 4, 4 to 0, subtracting 4, and 0 to negative 4, we're subtracting 4. So this table represents a linear function. As X increases by 2, Y decreases by 4. And for number 3, if we look at our graph, we can see that we do not have a line. So this would be nonlinear. The graph is not a line. Now for our third example, we're looking at linear and nonlinear functions. Which equation represents a nonlinear function? We have A, Y equals 4 7/10. B, Y equals pi times X. C, Y equals 4 over X. And D, Y equals 4 times the quantity X minus 1. The equations Y equals 4 7/10, Y equals pi times X, and Y equals 4 times the quantity X minus 1 can be rewritten in slope-intercept form. So they are linear functions. The equation Y equals 4 over X, or 4 divided by X, cannot be rewritten in slope-intercept form, so it is nonlinear function. So the correct answer would be C, because C is a nonlinear function. Now we have an additional example. You can pause the video and try it on your own, or you may follow along. Does the equation represent a linear or nonlinear function? Explain. So for number 4, we have Y equals X plus 5. This equation is linear because it's in slope-intercept form. For number 5, we have Y equals 4X divided by 3. This would also be linear because the equation can be written in slope-intercept form. We can rewrite this as Y equals 4/3 X, or 4/3 times X. And for number 6, we have Y equals 1 minus X squared. This would be nonlinear. The equation cannot be written in slope-intercept form.